We're going to roll here today, Chapter 1, Section 6, Order of Operations. We are going to discuss kind of the process first, then get into our crunching and munching of specific examples. The acronym here, PEMDAS, tells me the correct order of operations for simplifying any numerical statement. P indicates I'm going to do operations inside parentheses first. Now, parentheses is a generic term for grouping symbols. You can have parentheses. You might have brackets. I kind of went out of order there. Brackets, these goofy things called braces, not the things on your teeth to straighten them, but parentheses, brackets, braces, radicals, absolute values. Those are all types of grouping symbols. So I'm going to simplify inside these grouping symbols first. After I simplify inside the parentheses or grouping symbols, I'm going to cover my exponents, any powers or roots. Then I'm going to multiply and divide from left to right. So you don't necessarily multiply first before you divide. You multiply and divide at the same time, going from left to right. Addition and subtraction, that is going to happen also after you multiply and divide from left to right. So please excuse my dear Aunt Sally. People eat mayo daily at Subway. Use any acronym you'd like, but more importantly, can you put on your Nikes? Just do it. Example 1, we have 8 divided by 1/2 times 3. No parentheses, grouping symbols, no powers, exponents. So I'm going to multiply and divide from left to right. So no, I'm not going to multiply first. I'm dividing 8 divided by 1/2. Let's think. Oh, I can't divide fractions. So I am going to take 8 times the reciprocal of 1/2, which is 2 over 1. 8 times 2 over 1, which is 2. 8 times 2 is 16. 16 times 3 is 48. Don't forget, multiply by the reciprocal, don't divide fractions. Example 2, again, no parentheses, but I do have an exponent. I have a floater, the opposite of 4 squared. So I'm going to take 4 squared, which is 16. Its opposite, negative 16, plus 24, divided by 3 times 2. No exponents left, so I'm ready to multiply and divide from left to right. So I'll take 24 divided by 3, negative 16 plus 8 times 2. 8 times 2 is 16, so I've got negative 16 plus 16, which is 0. Nothing. Nada. Nothing. Love it. All right, 4. Look out. We're going to hit you with a ton of bricks. We have 2 sets of grouping symbols. I have brackets, and then inside the brackets, I have a set of parentheses. When I have doubles like this, I'm going to work inside out. So I'm going to take 5 minus 2 first, which is 3. So 4 times in brackets 25 minus 3 squared. Here I'm going to go inside the brackets, parentheses, I'm going to take 3, and then exponents squared will be 9. So 4 times 25 minus 3 squared is 9. 25 minus 9 is a sweet 16. 4 times 16 will give us 64. So 64 would be the simplified expression for example 3. 4, some decimals, no problem. 5.4 minus 3 squared. No parentheses, so I'll take care of the exponent. So 5.4 minus 3 squared is 9 plus 6.2. I'm going to take addition and subtraction then from left to right. 5.4 minus 9 is a negative 3.6 plus 6.2. I will end up then negative 3.6 plus 6.2. I'm going to end up with 2.6. And if you're not comfortable, feel free. Calculators are fine, or you can definitely use vertical alignment. Example 5, we're going to plug in x equals 7 to this expression. 21 minus x is 7, so I'll write that in. 21 minus 7 plus 2 times 5. No parentheses, no exponent, so I'll multiply and divide from left to right. Looks like 2 times 5. So 21 minus 7, and then the 2 times 5 is 10. Add and subtract from left to right. 21 minus 7, 14. 14 plus 10, 24. 2 to go. And then we'll talk fraction bars and literal expressions and equations. Here I have an absolute value, which again is a type of grouping symbol. Absolute value 4 minus 7 is negative 3. Absolute value of negative 3 is 3. Again, that's the distance negative 3 is from 0 on my number line. So I'll have 3 squared divided by 3. 3 squared is 9. 9 divided by 3 is 3. Happy birthday. Final crunch and munch example, I have a square root, a radical. That is also a type of grouping symbol. I'm going to simplify underneath the radical. So I'll have 3 times the square root of 50 minus 1 is 49. Take the square root of 49, which is 7. 3 times 7 is 21. First 7 done, we'll come back with the remainder. All right, we're back, ready to finish up 1-6 order of operations notes. We're going to continue with talking about fraction bars. That's when I have a numerator value over a denominator value. Now, fraction bars act just like grouping symbols. So the fraction bar is kind of like a border, a big wall. You're going to simplify the north, simplify the south, and then unite, divide, put them together. Reduce, if at all possible. So first example, I am going to simplify here 5 plus 2 times negative 8 in the numerator position. So I'm going to have 5 plus 2 times negative 8, negative 16. Adding 5 and negative 16, I've got negative 11. Denominator, negative 2 cubed, so negative 2 times negative 2 times negative 2. Well, negative 2 times negative 2 is 4. 4 times negative 2, negative 8. Minus 3. Negative 8 minus 3 is also negative 11. So that expression simplifies negative 11 divided by negative 11 to positive 1. That's crazy bread. Looking at 2. I've got numerator 2 plus 3 times 6. So I'll take the 3 times 6 first, which is 18. So 2 plus 18. That is going to be 20. Over 2 squared is 4. So 20 divided by 4 is 5. Last one. In this set, I have absolute value, which is a grouping symbol type, so 5 minus 7. So 6 times the absolute value of negative 2. And absolute value, how far away is negative 2 from 0 on the number line? That's just 2. So 6 times 2, which is 12. Over 14 minus 2. Which is 12. And we have another example similar to 1. 12 divided by 12 is 1. Grab my notes here to read off the translation examples. So here we are going to write out expressions of what we are told. So we're just going to write down word for word, literally, what we are told. So example 1 says, I want to take 14 divided by the sum of 5 and 2. So a couple ways you can do this here. If you write out 14 divided by the sum of 5 and 2, as is, that is not going to work, because order of operations, you would take 14 divided by 5. So that would read like 14 divided by 5 increased by 2. But we want to take 14 divided by these two added together, 5 and 2. So to do that, I need to put parentheses around the 5 and 2. That way I'm going to take 5 plus 2, add them together first, 7, and then take 14 divided by 7. Another way you could do that is use our friend, the fraction bar, and just write 14 over 5 plus 2. That says then you have to take 5 plus 2 first, 7, 14 divided by 7 is 2. No need to simplify, we're just writing it out in this case. Example 2, we're going to take negative 9 times the absolute value of the sum of r and negative 4. So negative 9 times absolute value, again, are these vertical line segments, which tells us how far away from 0 a value is, distance. And we're taking the absolute value of the sum of r and negative 4. So r plus negative 4, or if you want to write that as r minus 4, AAA, okay. Last translation here, we have the difference of, so we're going to take the difference, subtract 7, and the quotient of 3 and 7. So you might think, ooh, do I need parentheses around the 3 divided by 7? Well, actually not, because in this case, order of operations, you're going to divide before you subtract. So you can leave it as is. Another way you might want to write this is using 3 divided by 7 as a fraction. So 7 minus 3 sevenths. There you have it. Lastly, angle type review. If you have an angle that is obviously greater than 0 but less than 90, that is what we call an acute angle. Exactly 90 degrees, as indicated with this little box in the corner. That is exactly 90, also known as a right angle. And then an angle that's greater than 90 but less than 180. This is an obtuse angle. So little angle review, there's a few of those on the assignment. Thanks for paying attention and grinding. Have a superb rest of the day.